Thank you for staying with Republic TV viewers as we are tracking here on Republic the biggest launch and the maiden solar exploration launch of ISRO of Aditya L1 that is going to cover 4 times the distance of Chandrayaan missions as well, and is going to take at least 4 months, 125 days to be specific, when the data will start pouring in for the scientists to also start analyzing it for understanding space weather and vis-a-vis the relation with Earth as well. In fact, we are getting you some of the biggest voices on this story as well. Let's take a look at this first special report that has been filed to understand what's happening with the solar exploration. And in fact, we also have with us Group Captain V.N. Jha, Senior Scientist, and also the former Joint Director of the DRDC. And also we have R.C. Kapoor, and who's also a space scientist, joining us. Good morning, gentlemen. As we are tracking here on Republic, I thank you for joining us. And we are tracking the solar exploration mission that is all set to be launched today. And you know, if I could come to you first, R.C. Kapoor, sir, if you could speak to us a little bit about the importance of the solar exploration mission that is all set to be launched today, India's maiden solar exploration, and what exactly can we expect that this will tell us, this mission, and will help us understand as well the data that will pour in. If you could speak to our viewers about that.
Well, thank you very much for giving me this opportunity. And Aditya L1 is India's very ambitious mission, and ISRO is going to launch it today in a few hours from now. And it will take about 4 months' time to reach its destination, which is L1. L1 means Lagrange 1, which is after the French mathematician who discovered those points. In the Earth, Sun, two gravitating bodies, gravitational field, when he worked it out, so he found it at this point, and a few others. They are called L1, L2, and L5. L1 is the place where the gravitational field of the Earth and the Sun equalizes. On the Earth-Sun axis, 1.5 million kilometers from the center of the Earth in the direction of the Sun, that is the L1 point, and that's where Aditya L1 is going to be placed. Aditya is for the Sun. So obviously the study is for the Sun, and there are all 7 instruments in this satellite that are going to be utilized for studying various aspects of the Sun's radiation in the form of either electromagnetic radiation or the particles that come from there. These high energy particles that reach the Earth, they affect our environments. Now, our present-day life is technologically sort of in such a way, we are so much involved that it is necessary to know the condition of space weather also, and like we want to know about general weather on the planet. So space weather is very important because there are disturbances caused by the Sun's emissions, and therefore we must have some advanced warning, because it can affect our satellites and so far as communication is concerned, and many other things. So obviously the study is very multifaceted, and of course the main instrument on this is VELC that my institute, Indian Institute of Astrophysics, has built, and of course other laboratories also have joined in from ISRO side, and it is for the study of the solar corona. Solar corona, may I just show you in this image? You can see it. You see the dark disk in the center is the moon, and what you see around it is the corona of the Sun, and that is a very hot atmosphere of gases, and these gases are at, say, 1 to 2 million degrees centigrade, and we have to study that.
That's right.
Usually we would see the solar corona at the time of a total solar eclipse, for which thousands of scientists and those who are interested in watching that event travel thousands of kilometers, and therefore, and we get a sort of to see the corona of the Sun starting for a few seconds to at the most 7.5 minutes. So on the average, we are getting about 1.5 to 2 minutes. So if that is the only duration available to us, there are many things we are not able to study. For example, if we are able to observe the corona for a much longer time, that
That's
coronagraph
right.
offers. Coronagraph has a occulter disc inside it, and there is a very complicated optics, and that disc covers the bright disc of the sun, so that in the absence of the because the light scattering is much reduced, so we are able to see a much fainter solar corona. For example, at the time of total solar eclipse, the sunlight drop is by a factor of about 400,000, and obviously you can understand that solar corona that we equalize with the full moon brightness in the very rough terms. So you can understand how difficult or rather impossible it is to
Well,
observe the
absolutely,
solar corona
Mr.
at any
Asi
other
Kapoor.
time,
Of
and
course,
therefore
what
the
you're also telling us,
coronagraph is
extremely
necessary.
difficult and a very ambitious launch and an ambitious project for sure, as we're looking at India's maiden solar exploration launch as well. And in fact, stay on with us as I also bring in Group Captain V.N. Jha, who's also a senior scientist and former Joint Director, DRDO as well. Good morning to you as well, sir. Thank you for joining us here on Republic. And if I could ask you, sir, because, there has been a lot of commentary about India's space exploration right from the inception of ISRO, right from the time that Vikram Sarabhai had set up these organizations, and he had looked up to the sky and had stated that space exploration will also help in the development on Earth as well. In fact, our Prime Minister also spoke about this during the Chandrayaan-3 launch, where he stated that this will help and this will give a big boost in industries like telecommunications as well. So there's a huge potential. But there have been a lot of naysayers for India's space exploration as well, stating that India needs to focus more on, problems back on Earth and not really look at the sky. But these kind of launches, these kind of ambitious projects really prove them wrong, don't they?
Thank you very much, Priyanka. Good morning to you, and I wish the entire nation, the ISRO, the very best of the success that they start the process of going to the L1 point with the Aditya mission. And I'm sure ISRO is a professional body, one of those rarest of the professional body in the world, which has got the capability, and it has proven time and again. So we have absolutely no doubt that it will succeed. And yes, this Aditya mission to Lagrange point we are going for the first time. We have earlier gone to, moon, we have gone to the Mars, but the path has been by and large directly heading towards those celestial body, whether it is moon or Mars. Lagrange point is something which is no body. I mean, there is no body at all. Just for the sake of your viewers, we scientists, we have a tongue which is too technical. It becomes too technical for the viewers to understand. I'll try to explain it much easier way that your viewers can be able to, understand what is going to happen. If this be the Earth, Earth has got its gravity, and that gravity ranges fairly bit of distance. It goes to, huge distance, even if there is a very little of the gravity there. Sun, on the other hand, Earth has got 1 g gravity, 980 centimeters per second square, what we call it. But the Sun, on the other hand, which is almost nearly 15 crore kilometers away from us, it has got its own gravity. Sun's gravity is almost nearly 28 times more than Earth. So the 28 times of the sun gravity keeps all the planet in its orbit. As you know, the Mercury, the Venus, Earth, Mars, and like this. All of them, they are going in and around the sun for billions of years, and it will continue going there. So that much is the influence area of the sun. That much strong it is there. But even to the sun's gravity, when the sun gravitational wave comes towards the Earth, and Earth has got its own gravity also, somewhere around, if this is the Earth, somewhere around 15 lakh kilometers away from the Earth's surface, Sun's gravity and the Earth's gravity, there is a small equilibrium area where they are cancelling each other, or there is an equilibrium set within a small space of the influence area, which we call it as Lagrange. And that Lagrange point is the one where if something is placed, it will neither be dragged towards the Earth nor it will be dragged towards the Sun. So it will remain by and large stable. Stable is not a proper word, because some other motions also keep on taking place in that Lagrange range. So that is where now we are sending the Aditya one, and it's not going to be a straight path. What is going to happen today is, today when we launch our PSLV, the PSLV will take Aditya in and around the sun's orbit. It will be elliptical orbit like the Chandrayaan that we had seen. I think it is designed to park the Aditya into about 15,000 kilometers, 50,500 odd kilometer of the apogee, the farthest point, and the closest point to the Earth will be about 200 odd kilometers. So that the attraction, every time that it passes through, that attraction pulls it towards the Earth and gives additional sling operation of the speed. And just like Chandrayaan 3, where the ORM, orbit raising maneuver, was being done, orbit raising maneuver ORM 1, 2, 3, 4, with this the slingshot of the payload keeps on pushing it out and out. It keeps on going further and further, but there is a limitation here. For Chandrayaan, we could put it to apogee of about 3 lakh plus kilometers. 3 lakh, I think 60,000, 65,000 kilometer was the apogee there. And in this case, the apogee cannot match anything of the Lagrange, because Lagrange is almost about, say, 15 lakh kilometer, and there can't be a path through the Earth. So after we put into the trajectory towards the Lagrange, then the motor, which is with the Aditya, it will continue guiding it towards that Lagrange. And there is an entrance, there is a particular way of entering the Lagrange, because I mentioned to you, there is a small two waves of the sun and the Earth, they cancel each other somewhere. So it has to enter in that and come to the area where it has to keep on staying there and uninterrupted looking at the sun, because then in between the Earth and the sun, nothing will come here in this. So it will continuously be looking at the sun all the time, and it will record all the events undergoing, as Mr. Kapoor had mentioned, all the events which is undergoing there, whether it is the photon emission, the light, electromagnetic radiation is a very large spectrum. Something of the visible that we have learned in the schools like Gibbs here, starting from violet to the red. Beyond the red, there is an infrared component as well, which is the heat part of the sun. And beyond the violet, there is ultraviolet rays also. So those ultraviolet rays, there are some beneficial to the skin, like vitamin E produces vitamin D, but in the much reduced form on the Earth, when it has passed through all those layers of the Earth's atmosphere. That is beneficial part, but then there is many more which is absolutely harmful part. So ultraviolet study will be there, visible spectrum study will be there. As Mr. Kapoor mentioned, the corona part of the sun, that will be studied. The entire sun which is lit, which we understand that it is the explosion on the sun is happening in the thousands of a hydrogen bomb type of reaction. You know, one hydrogen bomb can make the devastation so much, and there are thousands of hydrogen bomb type of reaction happening every second. And that is all around the sun. It is not only towards the Earth, it is all over the sun that is taking place. So that much of radiation keeps on coming out of the sun. There is a plasma. So there will be a study for the plasma also. And with all these things, the particulates emissions, which is the solar flare, that also has to be studied, because that is so devastating. That could be so devastating that can knock out all the satellites in and around the Earth's sphere. So not only that, there is a thinking that if one of those rare emission of solar flare is there, which is very strong. That also has the capability to blow off either the part of the entire atmosphere or the entire atmosphere to make the life absolutely impossible on the earth. So all those possibilities are, उसको कहते हैं ना कि वो शिव जी की जो तीसरी आंख है, वो तीसरी आंख हमारी तरफ को ना खुले तो वो बेहतर है. But all those possibilities are there. That is why equipment is going there. It will keep on sitting there in that Lagrange 1 point, keep on studying, at 24/7, all those properties of the sun, whether it is plasma, whether it is the magnetosphere, either of sun or the earth or the cancelling somewhere around Lagrange. All these studies will be done in the coming days. It is going to be a long journey to the Lagrange. We wish ISRO all the best, as the prayers are going on. Scientists have done everything that they can do. Now it is a bit of prayer and, well wishes, good wishes that is coming from all over the world for us to go there to the Lagrange. Lagrange is not the point where someone is doing for the first time. Earlier, NASA has sent its craft there. They have done the similar study, not the same, if not the same. So all those things have happened in the past. We wish ISRO all the best, that the entire thing, what starts from today, culminates into success after about 4 months. Yeah.
Oh, absolutely. Of course, this is an ambitious project. And